Hello and welcome. Today I want to talk to you about choosing the right chart type. This is something that causes some confusion. You got a great data set and you want to show it visually by creating a chart, but what type of chart do you choose? Your spreadsheet program will let you pick any one of a multitude of types of charts, whether they're appropriate for your data or not. So this module is intended to sort of give you a framework for deciding which chart to use based on asking a question about your data. We're going to be using today some crime data, some national crime data from the FBI, and some local crime data from the city of Portland, Oregon. We're going to use this data to generate a number of charts in order to go through the process. So we have to start off by asking a simple question. What do you want to show? And in broad terms, the answer to that question will fall into one of four categories. Comparison, do you want to compare categories, compare variables to one another, compare time points to one another? Relationship, looking at how different variables interact with each other, whether they're correlated or not. Composition is looking at the data as a whole. What percentage is responsible by one particular category or another. And distribution. Distribution is looking at the shape of a large data set. If your data has multiple categories, you're probably going to first want to do a comparison chart. This is the most common type of chart that you'll start with. When you want to compare multiple categories, or if you want to compare time points within a category, this can be useful. To illustrate this, we're going to use our first data set. This is the crime data from the FBI. This is annual crime statistics for property crimes from the year 1994 to 2013. Property crime is broken down into three types: burglary, larceny, theft, and motor vehicle theft. And we have the actual numbers and the rates for each one of these. So what if we wanted to look at the different crime types in the year 1994? So we have 1994 here. Here are the numbers we're interested in: burglary, larceny, theft, and motor vehicle theft. And if we want to compare those to each other, it is useful to make a column chart. A column chart has the crime types across the horizontal axis and the number of crimes on the vertical axis. And they're usually not touching. These bars do not touch each other. So this is a good place to look at what all charts should have. A title that tells you exactly what we're looking at in the chart. Clearly labeled axes. What are our categories, and what numbers am I looking at here? So those are things that are common in all of your charts. Should have this. They should be clearly labeled. Column charts can also be used to show changes over time. So let's say if we want to look at property crime rate as it varies across the years in our data set. We can make a column chart that looks like this, but there are quite a few columns here, and it's more appropriate when you have this type of data to use what's known as a line chart. We replace the columns with points, and we connect them. This is only appropriate when there is a continuous data set along one of your axes. This doesn't make sense if these are categories not connected. So this works for temperature, for time. And you see that this graph shows a really nice story of declining crime rate over time. Multiple line charts can be included on the same chart as long as both axes are the same for all the data. In our case, we're looking at the three different property crime types: larceny, burglary rate, and motor vehicle theft on the same chart. This is a good way to get lots of data onto a single chart. So what if we want to look at the relationship between different variables in our data set? We want to see whether one variable correlates to another. The most common type of chart to do this is called a scatterplot. So in our case, we might want to look at the relationship between property crime rate and unemployment rate. You might think that as unemployment rate goes up, property crime goes up. So what we do is make a chart that plots the property crime rate and the unemployment rate as a single point. So we take each year and take these 2 points, the crime rate and the unemployment rate, and plot them as a single point. and it looks something like this. So each one of these dots here is a single pair of unemployment rate and property crime rate plotted together. Now, unlike the line chart, it doesn't make any sense to connect these dots because any one of these, any pair can occupy any place along either axis. So the lines would go all over the place, and it doesn't make any sense to connect them. What you often see is a line of best fit. How does this data fit together? And in our case, it doesn't really fit together. There doesn't appear to be any relationship between, at least in our data set, the crime rate and the unemployment rate. These data are all over the place. So that in itself can be a story. So what if we want to look at the composition of our data? The most common type of chart for doing this is a pie chart. Here we see a pie chart of the crime rate breakdown for the year 2013 based on our FBI data. And so it's easy to see that our property crime is composed of 3 and only 3 categories: burglary, larceny, and motor vehicle theft. And it's easy to see that larceny is the largest part of that. So this is how a pie chart might come out of your spreadsheet application. But I urge you not to make your pie charts look like this. Never use a key with a pie chart. Always use a call out to label the parts directly, or even better yet, put the names of the categories right on the pie slices. Other types of composition charts are better for comparing multiple categories. You don't want to put 2 pie charts next to each other. It's very difficult for the eye to estimate volume of pie slices. It's much better to use a stacked bar graph to compare multiple categories. And if you're looking at comparing time series, it's best to use a stacked area chart. So now let's take a look at how we show data distributions. In our previous examples, we have been showing a single point that represents an average of a large number of data points. But what if you want to look at the distribution of those underlying data points? To do that, we use a tool typically called a histogram. And to look at how we make a histogram, we're going to look at a new data set. This is local crime data from the city of Portland, Oregon in 2013. And I've pulled out all of the larcenies from the city of Portland in 2013. This table contains over 21,000 rows. Each row is a separate crime. And so let's say we want to look at what time do people commit larceny. There's a field called report time, so we have the times. Now you could take an average of all the times and find the average time, but that's not really going to tell us anything. So we use a tool called a histogram. And to make a histogram, you take the entire range of your data, in this case it's 24 hours, and you divide them up into bins. In our case, there's no magic number of bins, but since we're looking at time of day, it makes sense to make 24 bins, one for each hour. Then we count how many larcenies happen in each one of those bins. So how many larcenies were there between midnight and 1 a.m., how many between 1 a.m. and 2 a.m., etc. And we plot the frequency of those bins on a column chart. And it looks something like this. So we have frequency of data on the vertical axis, and we have time of day on the horizontal axis. Each one of these bins corresponds to how many larcenies were there at 9 a.m. is the height of this bar. And you can see that there is a minimum around 5 a.m. and there's a maximum around 4 o'clock, 3 o'clock in the afternoon. So this is a great way to show the distribution of that underlying data. Histograms typically have the bars touching, and that lets you know that this is a continuous set of data that is unbroken. These are not categories. To compare multiple distributions, a box and whisker plot is the best chart to use. A detailed explanation of this is outside the scope of this video, but I'll include a link to it in the supporting material. So this has been a very quick introduction into the most common chart types and when to use them. There are lots of overlaps and gray areas depending on your particular data set. But just start by asking, what is it that you want your data to show? Thanks for watching, and check out the supporting materials with this lesson. That includes a flow chart going through the process that we just went through, including some additional chart types. Thanks again.